Hey guys, so this is David again, and I will be doing video about one-way ANOVA in this particular video. Okay. So let me just give you a brief recap of what's happening in the t-test that we just covered last week and covered also in the last video that I have. So in t-test, okay, so we have pretty much three different t-test technique that we actually covered in this course. The first one is one sample followed by independent followed by paired t-test. Okay, and then we sort of covered that. Just change the ink color. Okay, so one sample is basically for, let's say, if we want to understand the population mean with respect to known mean. So for example, we talk about UNSW graduates, UNSW graduates actually earning $100,000. So that's 100,000. Okay, so maybe the mu is not equals to 100,000. Okay. Now, second case for independent, that's pretty straightforward as well. Okay. Oops. So for independent, the same thing. It's more on the differences between two groups. So for example, we say that the mu of UNSW for income, so income in UNSW graduates is equals to Sydney Uni, and of course the mu of UNSW not equals to Sydney Uni. Okay. Now for paired t-test is more on two variables. Okay. So let's say if we say income before coming to UNSW and income after coming to UNSW. Okay, and we have x1 and x2, and since paired t-test is more on analyzing the difference between two scale variables, so x1 has to be scale. Okay, x2 has to be scale as well. Okay, so independent samples on the groups. Okay, so if you have two different groups, paired t-test if you have two scales variable. Now the problem is that especially if you are looking at independent and paired, we can see that they always focus about two. Okay, well again, because it's due to the concepts of t-test, because t-test is always analyzing between two means. That's the fundamental usefulness of t-test. Then you might say, how about if there is more than two? Now if there is more than two, let me just change to a different color. Now if there is more than two, okay, so that's where ANOVA comes in. Okay, so ANOVA stands for analysis of variance. Okay, so that's what I call analysis of variance, which is ANOVA. Now then you might ask, how about if I have more than two groups? That's the first thing that I have. Okay, so I have more than two groups. So for example, if I'm analyzing about customer satisfaction, okay, which is, let's say, 1 to 7 scale or Likert scale. Okay, and I have, let's say, I'm operating in New South Wales, I'm operating in Victoria, I'm operating in Queensland, and then I'm operating in Northern Territory. Let's say we have just 4 states. Now you can see that now we have 4 instead of 2. So clearly we cannot just use t-test. So this is the first case of ANOVA. Okay, in this case what we call is one-way ANOVA. Okay, so basically one-way ANOVA serves this almost similar concepts with independent. The only difference is that independent we only have 2 groups, for ANOVA, we can have more than 2 groups. In fact, we can have 7 groups, 8 groups. So if we have more than 2 groups, okay, so more than 2 groups, we have used ANOVA. Okay, that's the first one, which is using one-way ANOVA. Okay, for some reason this is gone. Okay, then the second one is that for concepts of paired, okay, I'm just using different colors so that at least you know what I'm talking about. Let me just change that. I'll just change it to blue. Okay, then for paired t-test, you might be asking, what is this? So if I have now, instead of having 2 scale variable, this is 2 scale variable. If I have more, for example, if I have 4, so let's say if I want to analyze x1, x2, x3, x4 concurrently, okay, I want to do this. Okay, now also we have to use ANOVA. Okay, so instead of 2, I have 4 scale variables, so we have to use ANOVA, and the word or the method that we're going to use is called repeated measures ANOVA. Okay, so I'm going to repeat myself. So the first one is that one-way ANOVA is similar with independent samples. The way how it operates is basically analyze between groups of a certain scale variable. Okay, so let's say we're going to analyze satisfaction. Now instead of having 2 groups, we're having 4 groups, so we have to use what we call one-way ANOVA. And the second one, which was paired t-test. Paired t-test initially analyzed just 2 scale variables. However, if we have more, let's say in this case we have 4, then we have to invoke what we call repeated measures ANOVA. Okay. Now for this video, we're only going to cover one-way ANOVA, and for the next lesson in class we will cover hopefully repeated measures ANOVA. Okay, so I hope that makes it a little bit clearer about what's going on in ANOVA versus t-test. So without further ado, let's go to take a look at the ANOVA slides. Okay, so first of all, we want to understand the average rating. Okay, oops, let me just change that to pen. So average rating of importance of maintenance cost differs by income. And as we know, I think income in our data set, I think we have 4 different classification of income. Okay, so now we have, instead of just 2, male and female, we have 4 groups. Okay, so clearly, since that we have 4 groups, we have to use one-way ANOVA. Okay, now the way how we set up null and alternate hypothesis is still the same as what we use in independent samples. So HO again is about equality. Okay, so the average rating of maintenance cost does not differ by income. Okay, and of course H1 is that the average rating of importance of maintenance cost differs by income, because H1 is about inequality and H0 is always about equality. Okay, or we can also say like this, which is the mu of income 1 is equals to mu of income 2 is equals to mu of income 3, and I think we got 4 groups, so you can put equals to the mu of income 4. Okay, and H1, okay, you have to write this word, which is if null hypothesis is false. Okay, so you cannot write, okay, so you cannot write like this. So you cannot write, okay, I repeat, cannot write mu income 1 is not equals to the mu of income 2 is not equals to so on. Okay, you cannot write like this. This is wrong. Okay, So you only write if null hypothesis is false. Make sure you remember that if you want to use mathematical expression. Okay. Now this data set is basically the car data set again. So basically you can use you can start following what I'm using here. Okay. So you open your car data set, you open SPSS, and pause this video because I'm gonna check out the pause the video if you want to sort of follow the steps. Okay. So here you go. So you go to analyze, you go to compare means. It's still in compare means, but if you look at the last few, the last one, which is what we call one-way ANOVA, that's what we're going to click. Okay, so I repeat, analyze, compare means, one-way ANOVA. Now then the easiest thing is that we have to click low maintenance cost, because that's what we're going to analyze. Okay, so remember, it's low maintenance cost, okay, instead of current satisfaction about maintenance cost. There's two different types of the data in here, so just be careful. So you have to choose the low maintenance cost. Okay, drag it here. And of course, what factors you want to differ by? It differs by income. So you drag income into these particular boxes. Alright, so I repeat. The first one, you take the low maintenance cost, you drag it in here. And the second one, you drag income and you drag it over here. Okay. And then after, you can click this. The next thing that you need to do is that you need to click post hoc. Okay. So which is in here. Okay. Click this post hoc. And just tick these two. Okay. The first one is Tukey, and the second one is Lamhain. Okay. Or Tamhain. I can't really pronounce this, but it's either one. It's tick this Tukey and tick this Lamhain test. Okay, and you click continue. And the next thing is that you click the option in here. Okay, so after you click the post hoc test, you click the option, and in option it come out like this. Okay, so what you do is you click both of them: homogeneity of variance test and means plot. Okay, that's the two that you need to know. And you click OK, continue OK, and a result should be pop up to you. Okay, so here is the argument. Okay, now you have the test of homogeneity of variance. Okay, now this is the same thing as what we call the Levine test. Okay, so we have the Levine's test that we have in independent. So if you remember independent, okay, so this is the same test that you do, but the first thing first, okay, make sure you remember this. The first thing first, okay, and the same thing here. This does not, the significance here, okay, so the significance here does not answer the hypothesis. Okay. Again, the significant or the p-value here does not answer the hypothesis. Okay. So in ANOVA, the first thing first that you should look is basically look at the ANOVA table. Okay. And if the ANOVA table and the significance here shows the p-value, and this is the one that answers this is the one that answers hypothesis. Okay, and again the F here is basically our friend of test statistic. Okay, so the test statistics is F, denoted as 1.696, and the significance is 0.187. Okay, now we know that 0.187 is less than 0.05, and therefore we failed to reject null. So what happened if we failed to reject null? Well, if we failed to reject null, coming back again to the first, the hypothesis. So if we failed to reject null, so if we fail to reject null, so therefore the average rating does not differ by income. Okay. So if it does not differ by income, then what you should do is that you stop. Okay. So first of all, okay, I think this slide outlines what you should do. Okay. So instead of looking at homogeneity or variance, you should look at the ANOVA table first before you're doing anything else. Okay. So again, you should look at the ANOVA table, which is the second one here. And since the p-value is 0.8187, which is more than 0.05, therefore we failed to reject our null hypothesis and conclude that there is no difference between income. Now, if it is not significant, i.e., okay, since the ANOVA result is not statistically significant, okay, not significant means that p-value is actually more than 0.05. Then you may ignore the other results that was generated by SPSS. Or in other words, okay, the result is, okay, open inverted comma, useless. Okay, then what do you do if it is useless? Throw it away and you have to rerun a new one. So basically there is no, I mean, there is nothing that to be found, because the fact that all the income groups are the same. So you cannot make a conclusion based on that. Okay, so in other words, the result is useless, throw it away and do a new one. Okay, as Homer here, let's start over. Okay, now let me show you the one that is sort of showing. Okay, so the question is that the current satisfaction with high gas mileage differs by income. Okay, so I guess you should know what to do with the null hypothesis and the alternate hypothesis. Okay, so HO is always about equality, so we can say the current satisfaction with high gas mileage does not differ by income. And H1, the current satisfaction with high gas mileage differs by income. Or you can also write mu of income 1 is equals to income 2 equals to income 3, H1, if the null hypothesis is false. That's how you should write it. Okay, so if you're using the same test again, you click the same button. Okay, now first of all, the first step is always to look at our ANOVA table. And our ANOVA table this time is statistically significant, okay, because our p-value is less than 0.05 and therefore we reject. When we reject our null hypothesis, it means that there is actually difference across income. Okay, now if there is a difference across the income, then the next question is probably the next question that comes to your mind is that in which income factors or in which income group that the groups differ. Okay, because we got pretty much 3 income group. Okay, so let's say we got group 1, group 2, group 3. And we want to know if there is a difference, in which specific difference there. Is it 2 that differs with 3? Or is it 3 differs with 1? Or 1 differs with 2? Or all of them are different? We want to know that. Okay? So that's pretty much the usefulness of the post hoc test, the one that we're going to do a bit later. Okay. So first of all, we established that there is a difference because the ANOVA significance is the one that answers our hypothesis. So this answers our hypothesis. Okay. Now after it answers our hypothesis, which is there is a difference, we want to know which income group differs. Okay. Now how are we going to do that? Okay, so after we look at the first one, which is 0.029, which is statistically significant, next thing is we are looking at the test of homogeneity or variance. Okay, now in here, okay, then we look at the significance. So we are looking at the Levine now. Now again, this Levin will tell you whether you're gonna use the Tukey or the Thumb-Haynes test, the ones at the bottom. Okay, so after this table you should probably have the post hoc table. Okay, now this result, the significant in here, determines the post hoc table. Which post hoc table are we going to use? Okay, now how are we going to read that? Okay, here you go. So first of all, we take a look at our ANOVA table, and ANOVA table shows significance. Okay, the p-value is 0.029. We know that, so we are going on. Now, and then after we look at the Levin statistics, okay, which is the homogeneity of variance. Now, the test of homogeneity of variance, if the p-value is less than 0.05, we will use Thumb-Haynes test. Okay, so you just have to memorize this. Okay, so if p-value is more than 0.05, then you will use Tukey's test. Okay, so in this case, our p-value for, so the p-value for Levin, okay, make sure p-value for Levin is 0.222, which is more than 0.05. Therefore, we are using Tukey's test. Okay, so what do we need to do? Okay, so the result for the post hoc test, which is this one, so this is the post hoc test. It provides us with two results, Tukey and Thumb-Haynes. So now what you do is you can basically ignore all the result that is here, because what are we using? We are using Tukey, right? Okay, so up to this particular table, so only we're looking at the top half, or we are interested in top half. Okay, and you got the significance, which is, again, this is the p-value. Okay, so what you're looking for is that you're looking for the difference, so in which there is a difference. So for example, we look at the first one, which is a group of 35-50K with 50 to 65K. Okay, so this is what they're comparing, 35 and 50 to 50 and 65. Okay, now we can see that the significance here is 0. Oh, I can't see it anymore. Let me just erase that. Okay, so the significance is 0.086. Do you see that? Okay, so 0.086, which is more than 0.05. Okay, now if it is more than 0.05, therefore they are not significant. Okay, so therefore this group, if this is not significant, therefore they are the same. Then we move on. The second one, which is 35 to 50 and 65,000 plus, they have significance of 0.994. Again, which is more than 0.05. Therefore, it is the same. Okay, so this group are the same. So the treatment of 35K and the 65K, they are the same. So what the purpose here we are looking at is that we are looking at the difference. So which specific group they are different. Okay, so we can look in here, which is the group of 50 to 65,000 and the 65,000 plus. That is the group that is actually statistically different. Okay, so this group shows there is a difference in that. Okay, so this is the one that we need to say. Okay, so the way how we're going to write this down, okay, and it's going to be the same because it's going to be a mirror image. So if we're going to take 65,000 and 50 and 65, if we just flip this thing, the result is still the same, 0.022, which is what we have earlier. Okay, so when you're actually rewriting the way how we actually do this, okay, okay, so the way how we write this is that the conclusion the current car satisfaction of, I forgot what's the variable in the front, okay, so of something, so you have to fill with the variable that's in front. The first by income, okay, or then after you can say specifically, okay, specifically with income 50k to 65k and 65k plus. Okay, so this is the group. So you say that there is a difference, particularly the income of this group and this group. Okay, so that's how you're going to read the post hoc test, or that's how you're going to read the Tukey and the Tukey table. So I hope this video helps you to understand the phenomena or what's going on of the one-way ANOVA. Okay, so what you need to do is that you please try to attempt tutorial 3 by yourself after you watch this video, of course. And if you have any question, please let me know, or if you have some clarification question, please do let me know as well, so that at least I can clarify that in class. Thank you very much, guys, and I'll see you in class next week.